Welcome back to our data cleansing playlist. In the last video, we have learned what data cleansing is and why it matters. Now let us set up our environment and install all the required libraries that we'll be using in this entire playlist. Let's get started. First, let me show you what you need to install. We will need Jupyter Notebook. This is our interacting coding environment. We'll write all our code in Jupyter Notebook. Then we'll be using NumPy a lot. NumPy is great for creating arrays, matrices, mathematical operations, statistical calculations, random number generations, and there are many other features that NumPy provides, and that is the reason we'll be using NumPy extensively. Then comes the Pandas. Pandas is for data manipulation. Pandas provides data frames like Excel spreadsheet in Python. It provides way to load the different type of data like CSV, Excel, JSON, SQL, and there are many other formats it supports. It is mainly used for data manipulation like filtering the data, sorting the data, grouping the data, or merging the data. It is good for data cleansing, and that is the reason we'll be using extensively Pandas in this entire playlist. Then comes the Matplotlib. It is mainly used for basic visualization. It provides different type of charts like scatter plot, line plot, box plot, and there are many other plots that will be helping to understand the data. Then comes the Seaborn. Seaborn is written on top of Matplotlib, which is going to provide a statistical visualization. And finally, we'll be using SciPy for scientific computing. Now let us see how we can install all these libraries. To install the libraries, we'll be using a pip command. We'll say pip install NumPy, Pandas, Matplotlib, then Seaborn, then SciPy, and Jupyter Notebook. Jupyter, and you can also go for Jupyter Notebook. So this will install all the libraries, and that will be sufficient for this entire playlist. Now let us understand how we can verify the installation. Open Jupyter Notebook by using Jupyter Lab, and let us create our first notebook. Let us call it as environment setup 02 environment setup. In this case, we want to verify the installation. So let us say this is where we can say verify all the libraries, which can be easily done by saying import NumPy as np, import pandas as pd, import matplotlib.pyplot as plt, then import Seaborn as SNS, and finally we can say from SciPy import stats. Let us see whether they are imported successfully by simply printing a message: all libraries are imported successfully. So seems like all the libraries are successfully imported. Now let us start with one library at a time. Let me give you a small overview of all the libraries, starting with NumPy. As I mentioned, NumPy is very important library which is going to provide support for arrays. ND array, it's called as n-dimensional array. Let us create a 1D array, which is an array equals to np.array, and will provide 10, 20, 30, 40, and 50. Let us inspect all these properties of an array. Like, I'll print the array first. This is how it looks like. Okay, let's try to print the data type of an array. So we can say array data type. When I say array data type, that means every item inside an array will have the same type, which can be printed by saying d type of an array, which means in this case it is integer 64. Let us see what is the shape of an array. Shape of the array. Shape will tell you the dimensions and the length of the dimensions, like array dot shape. This will tell you this is a one-dimensional array, and in that one dimension we are having 5 elements, which we can easily see by looking at the size of an array, which can be done by saying array dot size, which shows exactly the number of elements in the dimension, the first dimension you can call it as. If you want to print the number of dimensions, I can say number of dimensions, which is going to be equals to array.ending. So ending shows me it is a one-dimensional array. Now I can do the same job again for a two-dimensional array. So this is two-dimensional array. We'll provide it as an array with 10, 20 as my first row, 30, 40 as my second row, and 50 and 60 as my third row. So this is 3 by 2 array. So if you can see here, there are 3 rows and 2 columns. The data type of an array still is integer 64. The shape of array, because it's like two-dimensional array, there are 2 dimensions. So in first dimension there are 3, and in second dimension there are 2 items. Means there are 3 rows and 2 columns. Total number of values in an array is 6. It seems like all these properties will tell you the basic information about your array. Now this is a very simple introduction to NumPy. There is a separate playlist where you can learn NumPy from end to end. Now let us see what exactly the Pandas is going to provide. So let us create one more section for Pandas. Overview I can call it as. Okay. So in this case, we will try understanding what Pandas provides. Pandas provides the series, which is like one-dimensional array. But we'll be using DataFrame a lot, which is two-dimensional array. So directly I'll jump into DataFrame itself. Maybe I can just go back here and say create a sample DataFrame. It could look like this, df, which is going to be equals to pd.dataframe, DataFrame. And in this case, you can provide the data frame in terms of rows and columns. So let us say I want to provide a column called as a name, where I can pass the data like Alice, for example, or let's say Bob, or let's say Charlie, and the David. I think enough. David. Okay. Along with the name, I also want to provide the age of these 4 people. Let's say 25, 30, again 28, and 39. Next, let's provide the city. Let's provide city as, let's say, New York, or maybe I can say Los Angeles, or let's say Chicago, and let's provide let's say Phoenix. Finally, I can also provide the salaries of those people. Maybe I can say 50,000, let's say 60,000, let's say 65,000, and let's say 70,000. So as you can see, there are 4 columns, and in that 4 columns there are 4 rows. So if you look at this df, I'm going to go for the df. I'll say print df. That will give me the entire df here, which looks like this. There are 4 columns: name, age, city, and salary. If you just print the df itself without having the print, it shows a very nice looking data structure. It looks like an Excel spreadsheet. Yes, it is. Now the properties that we saw earlier in the NumPy, like data type, or means data type, or shape, or size, or endim, you can get most of the properties here because Pandas uses NumPy behind the scene. So for example, if I want to print what exactly the shape of it, so I can say shape of df, which is going to be equals to df.shape, and you can see the df of shape is 4 by 4. There are 4 rows and 4 columns. Similarly, if I want to provide the data types, now it's not a data type because there are multiple columns, so it's like a data types which can be printed by using df.dtypes. So instead of saying dtype, we will be using dtypes. It shows there is an age which is of integer 64, city, object, salary, integer 64, and name is also an object. Object means it is a string. So it shows the data types based on the columns. You can also print all the columns as well, like I can say columns, which is going to be like df.columns, and you can see there are 4 columns: name, age, city, and a salary. Wonderful. Now this is a simple introduction to the Pandas. This is going to give you an understanding of what DataFrame is. There is a separate playlist where you can learn Pandas from end to end. Now let us turn our attention to the next library, which is Matplotlib. So let us go back here and create a new section and call it as Matplotlib overview. Now in this case, I'll show you a small example of how Matplotlib can be used for creating a scatter plot. Now a scatter plot is kind of a dot plot where we need some data on x and y. So let us generate x and y values. Let's say simple values for x and y. So maybe I can say x equals to 1, 2, 3, 4, 5 and y equals to, let's go for some values 10, 20, 30, 40 and 50. Some random values that we want to use. Now let us go and create a scatter plot. So I can say create a scatter plot by saying plt dot scatter provide x and y. We can also print what exactly on the x by giving the x label. We can say sample x values. Similarly, I can provide the y label. I can say sample y values. We can also provide a title by saying title sample a scatter plot. Scatter plot. Then I can also enable the grid by saying grid, and I can change the alpha. Alpha means it's like the grid color 0.3. I don't want to go for a very dark gray, and that's why I'll go for alpha equals to 3. If I run this code, you can see that it shows a nice looking plot here. This is the scatter plot. If you really want to add the lesion, you can also provide one label to this and say label is going to be equals to y value, and you can also enable the lesion. And this is how it looks like. This is the lesion and this is the scatter plot. Good thing about the Seaborn is like you can get the similar plot or similar code for the plot and change only a function from scatter to plot, and it will do the same job, but instead of having a dot plot, you can see a line plot. Again, one more good thing about this here is you can combine multiple plots together. So this is going to be a scatter and plot. So you see that it has combined both the dots and lines together. Beautiful, isn't it? Now again, this is a very small introduction to Matplotlib. There is a separate playlist you can find where you can learn the Matplotlib from end to end. There are multiple graphs I have covered in a separate playlist. Now let us see a small Seaborn demo. Let's say it is a Seaborn overview. Now Seaborn, as I mentioned last time, is written on top of Matplotlib. So what I can do right now, I can create a data frame which is going to be equals to df pd.dataframe. I can say x here. I'm going to generate some data. It's like np.random.randn called as random n values. Total 100 values I'm looking for. Similarly, I'll go for y np.random.randn. I'll go for 100 more values on the y. Okay, and I also want to go for a category, just a categorical data, which is like np.random.choice, and I'll go for 3 options, A, B and C. So essentially I'm going to create a new column called as a category where you can see the values A, B and C randomly will appear, and total 100 such values I'm looking for. So if you explore df, this is what you can see, x values, y values, and then you can go for categories A, B and C. Now the good thing about scatterplot can directly identify the entire data frame here, so we can say sns.scatterplot. I'm going to use a scatterplot directly by saying data is going to be equals to df. Where is your x? This is my x. Where is your y? This is my y. X is the name of the column here, and this x means the x coordinate. Y is the name of the column, and this is going to be my y coordinate. The hue means it is going to change the color based on the category, like that. And I'll change the alpha. I don't want to go for the full color. I'll go for alpha with 0.6 values. Let us add plt.title, and then I can say Seaborn scatter plot. I think that's more than sufficient. If I run this code, you can see that it is going to do a great job. So instead of me doing all of that stuff, the Seaborn has done a lot of things for me. Like you see here, it has added a title on X, title on Y. It also has added the legend, and has done a fantastic job. Notice that though I'm using SNS here, I can also use a PLT, because as I mentioned, Seaborn is written on top of Matplotlib. Again, this is a very small overview of Seaborn. There is a separate playlist where you will learn Seaborn end to end. Thank you for watching. That is it for this environment setup. You have everything that you need to start a data cleansing. In the next video, we'll learn how to load the different file formats like CSV, Excel, JSON, SQL, and many more. If you have any question, leave them in the comment box. Like, subscribe, and I'll see you in the next video. Thank you very much for watching this video.